Start.
Hello everyone, welcome to our phase 2 project presentation for SkillAzure. Our team has implemented the complete SkillAzure database in PostgreSQL using pgadmin. SkillAzure is a decentralized skill verification and internship tracking platform that connects students, mentors, administrators, and companies. In this video, we'll demonstrate our database schema and how we populated the data and 6 example SQL queries that shows how the system works, including select, insert, update, and delete operations. So let's start by looking at our database structure. As you can see here, our schema includes all major entities from our ER diagrams: student, mentor, administration, skill, student, skill, internship, verification, certificate, verification ledger, company, internship posting, application, post, comment, and like. So each table has been defined with appropriate primary and foreign key, check constants, and data types to maintain data integrity. So, for example, in the internship table, the internship ID is an integer generated always as identity, which automatically assigns a unique ID to each record. Text attributes like organization and position and varchar, and we use a boolean column named verified to mark whether the internship is officially approved. Data are stored in the data type from start and end dates, and we include a check constant to ensure that end date is not earlier than the start date. So, foreign keys constant link each internship to a specific student. Similarly, key relationships exist between all dependent tables. The structure enforces referential integrity across our system and make sure that no one orphan records are created. So, it will be taken over by my teammate.
Next, we'll look at how we implemented the ER2 relational model. Here in the query tool, you can see the DDL script we used to create all the tables. So we also created a script for several triggers. The triggers are also very important for this project because one of them automatically updates an internship verification status when a mentor approves it. Another trigger ensures that posts can also be created for verified internships, and our verification ledger uses hashing to make it happen only and tamper proof for the passwords and stuff. And now let's walk through this DDL script, and let me highlight few key data types for creating the tables. Here, first, let's look at the student table. So here in the student table, int generated always as identity for the student ID, which automatically updates for each student, and it makes sure that each student ID is different from the others. And we used varchar 100, which means that a name can only have a maximum characters of 100. And then moving on to the skill table. In the skill table, we used varchar 100 characters, same as the name for the student table. And then we use 50 characters for the category. And these are text-based attributes with relatively short lengths. And the skill name column is set as unique, so the same skill can't be duplicated. And internship table is was just now explained by my other teammate. Moving on further, let's look at the verification table. For the verification table, timestamp was chosen for verified on because it includes both date and time, which is important when tracking the exact moment a mentor approved or rejected an internship. So let's move further and look at how we imported the data. So we didn't use any data set. We created rows by ourselves, and we used insert commands to export the data. Here, as you can see, and moving on further. So let me run this code. As you can see here, here's a live example. We just inserted a new verified company named Demo Works. You can see the result returned here with its new company ID as 9. And then when we run this confirms that the new record is saved correctly. We follow the same approach to populate all other tables so that our database now has hundreds of interlinked rows across all entities. Now, my other teammate will continue.
Hi, I'm running a few queries now to demonstrate the functionality of the skill ledger code. This first query lists all verified internships, joining the internship, student, mentor, verification, and certificate tables. It shows who the student is, which mentor verified the internship, and how many certificates are associated with it. This verifies that our triggers are worked correctly. Only internships marked as verified appear here. Let's do the second query. This second query summarizes internship application per posting. It uses conditional aggregation to count how many students are at each stage, applied, under review, interview, offer, or rejected. This helps companies quickly analyze their application pipeline and shows that our many-to-one relationships between postings and applications work properly. Okay, now, next one now, this code. Finally, this leaderboard query combines analytics and engagements data to rank students by verified internships, posts, and comments. It uses comment table expressions and the rank window function to calculate an overall engagement score. This query gives administrator a quick way to identify top performing and most active students on the platform. And from here, my colleague will take it.
Hello everyone. We'll now demonstrate an insert operation by adding a new application record. So yeah, this represents a student applying for an internship posting. We used a unique constraint on posting ID, student ID, to ensure that the same student cannot apply to the same posting twice. So the returning statement confirms the new row was successfully added, if you look at it. So next we'll show how our triggers automate workflow logic. So yeah, if we remove that code and run that, it shows as rejected. So now, in order to update it to from pending to rejected, like pending or rejected to approved, so we now add the code and yeah, it says approved now if the verification ID was changed. And once this runs, our trigger automatically updates the linked internship status to verified and sets verified as true. Also, yeah, if this confirms that our database enforces business rules without manual intervention. So finally, we are going to work on delete command. Yeah, if the comment ID 2 is removed, 4 is removed, or yeah, then it removes a specific comment from the system. We Yeah, so now we use returning to display the deleted record and then verify that it no longer exists there, like all the rows got deleted. And like this demonstrates how our system safely handles deletions while maintaining referential integrity across tables. And now my next speaker will continue.
So to summarize, in this phase, we implemented the entire skill ledger database in PostgreSQL and defined all constraints and populated with real synthetic data. We ran 6 queries covering data retrieval, analytics, insertion, updates with triggers and deletions, each reflecting how skill ledger supports verified skill tracking and student engagement. Our database is now fully functional and ready for integration with a front end or a blockchain verification layer in the next phase. Thank you for watching our demonstration for the Skill Edge Phase 2 project.